In this video, we'll be talking about the questions based on the motion with a constant acceleration. So the first question will be this one here. Now, if you look at this one, it says on dry concrete, a car can deaccelerate at the rate of 7.0 meters per second squared, where on wet concrete it can deaccelerate at only 5.0 meters per second. The first question says find the distance necessary to stop a moving car at 30.0 meters per second. A, which is on the dry concrete. So I'll say this is the dry, right? So what kind of the initial velocity that you have? Since they are saying it was moving, meaning that that's our initial what? Velocity, which is what? 30. Oh, that is our initial velocity in short, which is what? 30. Now, what would be our final velocity? Since an object is moving, meaning that our final velocity is 0, right? And remember that it was deaccelerating, meaning that it was reducing by how many? 7. So meaning that it was reducing on the dry concrete by 7. So that one will say negative 7 meters per second squared. Alright? Now, after you have done that, we have the initial velocity and the final velocity and the acceleration. And what are we looking for exactly? We're looking for the distance necessary to stop a car. Meaning that the distance that is necessary to stop a car, that is what we call the distance of the braking. So in short, we are trying to stop the car. That's the distance of what? Braking. So since that's the distance of the braking, meaning how do we calculate the distance of the braking? By using our simple formula. The one that has initial velocity, the final velocity, and the acceleration, and also the what? The displacement. That's the one that we shall use, which is just v final squared plus v initial squared, or here is supposed to be equals, equals v initial squared plus 2ax, like that. So what is our initial velocity? Final velocity, is 0. Initial velocity, that is 30 squared. Here there's plus. Then our acceleration, which is that. So this is 0. That's 900. Minus 2 times that, it will be what? 14x. So what will happen is that I'll bring this 14 to this side. So it will be 14x positive equal to 900. Then you divide by 14. You divide by 14. This and that, they will divide it, meaning that your x will be, what will be your x? It will be 64.3 meters. So this x that I found, I find that the displacement of the braking here is equal to what? 64.3. That's what it means. Okay. Now the second one, they've said on the what? On the wet concrete. Since it is on the wet concrete, what are we looking for? We're looking for the wet concrete, right? What is the data that you have? Initial velocity, it still remains to be 30. Then final velocity is what? 0. How about our acceleration on the wet concrete? It is what? Negative 5 meters per second squared. Why is negative? Because as I said, it's deaccelerating, which means that it is reducing. So which formula are we supposed to use? V final squared equal to V initial squared plus 2ax, like that. What is the what is the final? Remember the final is 0. What is our initial? 30. Our acceleration, that. So you have 0 this side, then this side is what? 900 minus 10x. So this 10x will come this side, meaning that it will be positive 10x equal to, then you divide by 10, you divide by 10. So your x is 90 meters. So 90 meters, it means that that was the distance that was necessary to stop a moving car. Now when you go to C, which is this one, it says repeat both calculation and find the displacement from the point where the driver sees a traffic light turn red, taking into account his reaction time of 0.500 second to get his foot on the brake. So what was the reaction time? 0.5. So we need to find the displacement or the distance at which he traveled in 0.5. So that one, you just use the simple one, which is this. They were moving at what? 30. Then time is 0. So it will be 15 here meters. So what you do, since this is the braking displacement on A, right? So since we are repeating, so this is a dry concrete. So the total, in short, it is a displacement of the braking plus displacement of the what? Reaction. So on the dry, what was the displacement of the braking? It was 64.3 plus 15. You have 79.3 meters. Then on the weight, the total again, so to be total here equal to, for the braking it was what? 90 plus 15, which is 105 meters per second. Meters. So that's how we answer that particular question. Okay, now let's look at this one here. A cheetah waits in hiding behind a bush. The cheetah spotted a gazelle running past at 10 meters per second. At the instant the gazelle passes the cheetah accelerates from the rest at 4 meters per second to catch the gazelle. The first question says, how long does it take the cheetah to catch the gazelle? So in that situation, what do you do? Okay, now you have a cheetah. And what else? The gazelle. Right? So a cheetah started from the rest, meaning that our initial velocity is 0 since it started from the rest. What was the acceleration? The acceleration was 4 meters per second squared. And the gazelle, it was moving at 10 meters. So since it was moving, meaning that our initial velocity is what? 10 meters per second, right? Final velocity, it is 0 because it was moving. How about the acceleration? The speed was not changing. Since the speed was not changing, meaning that our acceleration is what? 0. Just like that. Okay, now we will need to find the equation of the cheetah and we also need to find the equation of the gazelle. So how do we do that one? We have to say displacement final equal to VIT plus 1 over 2 AT squared. What is the initial velocity? It's 0 times time plus 1 over 2. Acceleration is 4. So you have 0 here plus, when you divide there, it will be 2t squared. So meaning that displacement of the cheetah is equal to 2t to the power 2. So that is your first equation. Then you also do the same thing to the other side. So on this side, our acceleration is equal to what? 0. So you can just say F displacement final equal to VIT. So this one, right? So what was the speed the Gazilla was moving? It was at 10 times time. So that is your second what? Equation. So you have the first equation and the second equation. So the question is, how long does it take the cheetah to catch the Gazilla, right? So in that situation, we get equation 1 and equation 2, like that, right? So what was the equation 1? The equation 1, it was 2t squared. Equation 2, it was 10t. So what you do is we equate these equations to find the time at which the cheetah managed to catch the Gazilla. So I've gotten this 2t to 10t. Then the other one will come this side, go to 0. What's common? 2t. So you have 2t equal to 0, then t minus 5 equal to 0. So I'll find this side, t equal to 0, and when that one goes the other side, it will be 5 seconds. So this means that the cheetah started from the 0 and it managed to catch the Gazilla at 5 seconds. Okay. Now the answer there, it is t equal to 0 and t equal to 5 seconds. That is the answer there. Okay. Now let's look at the second one, the displacement, right? So remember the displacement. What was the equation? The equation of the cheetah. The equation of the cheetah was 2t squared. And what was the equation of the Gazilla? It was 10t. So on that one, these were the equations that we had in the first question there, right? So since that was the equations that we had, meaning that the displacement we calculate from here. What was the time that the cheetah managed to catch the Gazilla? It was 5. So I'll put 5 there. It will be 2 there. What will be the answer there? 25, which is what? 50 meters. Right? That's all. Even this side, again, if I use for the Gazilla, it will give me the same answer. So there, it's up to you if you want to use both of them or if you want just to use one. It's up to you. Then the other thing, they are also asking us to calculate to sketch the velocity time graph, right? So the velocity time graph, the way you move with the velocity time graph, it will be, this is the velocity and this is the what? Time. So you have the velocity and the time. So what will happen is that, what was the velocity of the Gazilla? The velocity of the Gazilla, it was 10 meters per second. Then, meaning that it was just constant like that, right? It managed to be caught at what time? 5. What was the displacement or the acceleration of the cheetah? Remember, it started from the rest, meaning that from here, then it will start increasing until it managed to catch the Gazilla at this point. That's all. So this is what we call velocity time graph. How about the distance? The distance, what you do is you just put distance inside. And both of them, they moved at what distance exact? Which is 50 meters. So It managed to cut at what time? At 5, which is time. Just like that, simple and straightforward. Okay, now let's look at the other one. The other one, which is this one, it says a motorist traveling at constant, right, 15 meters per second, passes a school crossing where the speed limit is 10. Just as the motorist passes the school crossing sign, a police officer on the motorbike stop there, start in pursuit with the constant acceleration of 3.0 meters per second. The first question, how much time elapsed before the police officer passes the motorist? At that time, what is the officer's speed and how far has each vehicle traveled? So the first question says draw a displacement time graph for the situation. Second one, draw a velocity time graph for the situation. Okay, now in here you have the motorist who was moving at what speed? Constant speed of, that is the initial, right? Constant speed of 15 meters per second, right? What would be the final? The final will be 0, right? What would be the acceleration? It will be 0 because it was moving at constant 15 meters per second. Okay, now also look at the police. Right? So the police started from the rest, right, which were just standing, right? Our initial velocity there, it is what? 0. Then our acceleration is what? 3.0 meters per second. So to this side, the one with the acceleration equal to 0, this is the formula that we use every time. So it will be 15 what? T. So displacement this side of a motorist, it is 15 T. That's the first equation. Then the second equation, the police officer, right? So on the police officer, what we do there is displacement final equal to initial 1/2 80. So this side will be 0 times time plus, what's the acceleration? 3 t squared. So to be 0 there, then half times that to be 1.5 t squared. So meaning that the second equation in that situation, it is 1.5 t. That is the second what? Equation. After doing that, that's where you come to, you have two equations, right? You have two equations. So you have displacement of the motorist, which is 15 t, and displacement of the police officer, which is 1.5 t squared. So in that situation, we shall equate now. So it will be 1.5 t squared equal to 15 t. So what will happen to be minus there, right, equal to 0. What's common? T. So it will be 1.5 t minus 15 equal to 0. So time equal to 0, then 1.5 t minus 15 equal to 0. So you have 1.5 t equal to 15 there. So 1.5 divided by 1.5. So when you divide there, what answer are you expected to get? So that is what? 15 divided by 1.5, which is what? 10 seconds. So this means that the police officer managed to catch the Gazelle at what, or managed to catch the police officer managed to catch the motorist at 10 seconds. They started from the rest and they managed to catch them at what? 10 seconds. Okay, on the same questions, they are saying at that time, what is the officer's speed? So the officer's speed, we say final equal to initial. This is what we call officer's what? Speed now. So I'll say officer's what? Speed. So you say V final equal to V initial plus 80. Now, what was the initial velocity of the police? It's 0. They were moving at what acceleration? 3. At what time? 10. So it will be 0 plus 30. So the answer is what? 30 meters per second. So this is the answer there. How about the other one? It says, what is the officer's speed and how far has each vehicle traveled? So on that situation, on how far has each vehicle traveled, we shall get these equations which are there. So we have x final equal to 15t. So where there is t, I'll put 10 because that's the time at which the police officer managed to catch the motorist. So it will be 150 there meters. Even if I use the other one again, it will still give me 150. So it will be 150 again meters. Okay, so that's how we will answer that one. Now let's draw. We have been asked to draw, right? So since we have been asked to draw, now they're saying on B now, right? Draw the displacement time graph for this situation. So the displacement time graph for this situation, it will be displacement, meaning that they moved at what? 150. That's a displacement, right? And the time they managed to catch at what? 10. From 0. So this is the time, right? How about C? The velocity time graph. So the velocity time graph in this situation, okay, these people, 2 of them, the motorist, he was just moving at 15 meters per second. So to put 15 meters just there, right? Constant like that. But the police officer started from the rest and managed to catch the motorist. So this is the motorist. And this is the what? Police. They managed to catch the motorist at what? 10 meters per second. So that's how we answer this question. Simple and straightforward. Okay, now let's go to the other one. So on the other one, this one. So this one, they're saying you are driving at a constant speed of 45.0 meters per second when you pass a police officer on a motorbike hidden behind a billboard. 1 second after your car passes the billboard, the police officer set out from the billboard to catch you. Accelerate at a constant rate of 3.0 meters per second. How long does it take the police officer to overtake your car? Right? So in that situation, what we redo here is this. You have the car here, that's a car, right? That was moving at what speed exactly? That's the initial velocity in short. 45, right? Final velocity equal to 0. In acceleration equal to 0. Okay. Then the police officer again. So this is the police officer, right? And this is your car. So you are moving. The police officer started from where? Started from the 0 since they were just standing. Then the acceleration, it is 3.00. So here, what will happen is that you were moving, right? At 45, and the final velocity is equal to 0. And what we're having here is what? What we're having here is the initial velocity, final velocity, and acceleration. So here they're saying that after 1 second, that's when you started what? That's when the police officer started what? Chasing you. So how do we calculate the time here? Meaning that you left the police officer after 1 second. So for you, you need to calculate what we call the total time. So the total time, it will be t plus 1. That 1 second, if we had 2 seconds here, we could have put 2. But here we have 1 second. So we have just to put what? 1 there. So you have to say t plus what? 1. That is the total what? Seconds. So here the acceleration again is equal to 0, meaning which formula are we supposed to use? This formula. And you are moving at what? 45, that's an issue. And what's the total time? It will be t plus 1. That 1 second, that's what it means there. So you have 45 times t. Then 45 times 1, it will be what? 45. Just like that, right? And this side, it is the same equation with the acceleration now. So the final displacement is initial velocity is what? 0 plus 1 over 2. Final 0 plus 2 into that is 1.5 t squared. Like that, right? That's what it means there. Okay. Now, after doing that, we need to equate these formulas. So you have this part 45 t plus 45. Then the other one 1.5 t squared, right? So what we do, we equate to find the time at which the police officer managed to overtake your car. So I've got 1.5 t squared and I've equated to that with 45 t. Like that, right? So to be 1.5 t. Then the other one will come this side, that is 45 t, then that is 45 equal to 0. So this is our A and this is our B and this is our C. So meaning that we need to find this one by using what we call the Bus formula. So since it's a quadratic equation, so we need the Bus formula. So the Bus formula, it is t equal to negative b plus or minus, that is b squared minus 4ac over 2a. What is b? B is negative 45 plus or minus, so you put there negative 45 squared minus what is a? 8 is 1.5. Then times negative 45 there over 2. What is a? 1.5. So what will happen is that negative times negative, it would be what? 45, plus or minus, like that. What is 45 squared? 45 squared, it is 25. Then negative 4 times 1.5, then times negative 45. It will give me positive what? 270 over 2 times 1.5, 3. So it will be 45 plus minus. When I add 2025 plus 270, it will give me 2295. Then the square root now of that one, of 22295, it will give me 47 point what? 906 over 3. So if I say 45 minus, it will give me a negative. Remember that we're calculating the time. So what answer is supposed to give me? I'm supposed to have a what? A positive, right? So what will happen is that I'll come this side, don't worry. So I'll have 45 plus, I'll just only add, not subtracting, because to avoid to give me a negative answer. We don't have any negative time. So when I add there, it will give me 92.906 divided by 3. So what answer? It is 30.97 seconds, which is just the same as 31 seconds. So meaning that the police officer managed to overtake your car at what? 31 seconds. That's what it means there. Okay. Now let's look at question 2, the drawing part. So 2, that is the velocity, and this part, that is the what? Time. So remember that your car, you're moving at constant speed, which is what? 45, right? And the time, it is 31. So since it was constant, okay, it started from the rest, meaning that it was just moving like that up this point, right? So that is the car, and that is the police office. That's all. So that's how we will answer this type of what? Question. Straight and simple.